everybody, it's Mrs. Hofferberth. We're going to talk about pure substances and mixtures in this video. When we talk about a substance, we can classify it either as being a pure substance or a mixture. In a pure substance, all of the particles are identical to all of the other particles in that material. Whereas in a mixture, there are two or more different types of particles present. So if we look at the pictures I have at the bottom of this screen, we'll see that the material on the left and on the far right, those are going to be mixtures. These are mixtures because in each of these samples, there are more than one type of particle. So on the one on the left, I have blue particles and I have red particles. And so they're mixed together. On the right, I have 4 different kinds of particles. I've got blue ones, green ones, some yellow ones, and then I've got a particle that's made of red and 2 orange smaller atoms. And so we can talk about a mixture and you can recognize it on a particle visualization level because you've got more than one type of particle. On the other hand, the central picture here, the central particle visualization, was a pure substance because every particle is the same. So in this case, each particle in this substance is made of 1 red and 2 blue atoms. And so all of those particles are identical to all of the other particles in the sample, and that makes this a pure substance. Once you know you have a mixture, we can actually further classify that either as a heterogeneous mixture or a homogeneous mixture. Heterogeneous indicates that those particles are unevenly distributed within that mixture, where in a homogeneous mixture, those particles are evenly distributed. So obviously, drawings being what they are here for the particle visualizations, you can see that in the top 2 images, one type of particle is more prevalent in one area of my sample than in the other. And so on the one on the left, the blue particles are kind of towards the bottom, while the red ones are more towards the top. And then on the one on the right, the green are more towards the right and the yellow are kind of more towards the left. So those are unevenly distributed throughout the sample. On the other hand, a homogeneous mixture has those particles evenly distributed. So to the best of my drawing abilities, these mixtures have the particles evenly spread out. It is worth noting that when we're talking about an actual sample, an actual material, that whether something is heterogeneous or homogeneous often depends on whether you're looking at it on a macroscopic scale, what we can see, or on a microscopic scale, where you're really kind of zooming in on a closer, more detailed look at where those particles are. So scale does matter when it comes to classifying things as heterogeneous or homogeneous. But what are those particles? So there's 2 different types of particles that can go into making either pure substances or mixtures. There can be elements and there can be compounds. An element cannot be separated into a simpler substance by chemical means. These are the smallest the particles and the simplest the particles get. And these are our building blocks. This is what everything else we're going to do in chemistry is going to be built out of. So these elements can be individual atoms. You can also talk about elements or elemental substances that are the same type of atom in pairs, like my sample here over on the right. So this would be called a diatomic element because 2 of those element atoms go into making a single particle unit. You can also have elemental substances that contain even more atoms, but it's always the same type. So you can't separate it into a simpler substance. You have your basic building blocks in the elements. You can also talk about compounds, and this is where you take 2 or more of those elements and you combine them to make a more complicated particle. So these can be relatively simple, like the picture on the right where it's 1 blue and 1 red element, whatever those are. Or it could be much more complicated. I've got one that's a red, 2 oranges, and a green. You can actually have compounds that are made of hundreds, thousands, or even millions of atoms of different elements all combined together. So these compounds make particles, discrete units, that are made of multiple elements. You'll often recognize the elements because you've heard them before. They're the things on the periodic table. And so we're going to be taking a look at that periodic table, since this is our foundation for all the chemistry that we can do moving forward as we start looking at exactly why things do what they do. So in summary, we can talk about materials being either pure substances or being mixtures. In a pure substance, all of the particles are the same, whereas in a mixture, you've got more than one type of particle. And those particles can be either elements or they can be compounds, an element being the simplest substance you can have, and a compound being a particle made of two or more of those elements.